Welcome everyone again. Welcome to my channel. And in today's video, we are going to talk about the first lesson in statics. Yeah, that is the introduction to statics. Yeah. So before we go further, I'm going to go like what we are going to cover in this video. Just as I said, this is an introductory video. Yeah, it won't have any calculations. Yeah, just some few things, which is the introduction to statics, and the next topic, that's where we'll dive in details. Yeah, so what are we going to learn in this video? We're going to define statics, and also we are going to have engineering idealizations, problem solving method, and these others, mechanics versus dynamics and stuff. Yeah, so this is our lesson 1 in statics. Yeah, so before we go further, we need to understand where statics is coming from, and it is coming from mechanics. Now, what is this mechanics? Yeah, so mechanics is just a branch of physics that studies how forces affect bodies, explaining why objects move or stay still. So, but this mechanics now, it splits into what? It splits into two, and this thing it splits in. The first one is statics, the one that I just that we are going to focus on, which is statics, and another thing that we are going to focus on is dynamics. Now, what's the difference between these two? Yeah, so let's start with statics, the first branch, which is what? Statics. So when you're talking about statics, the first branch is what? Statics. This studies bodies in equilibrium, either completely at rest or moving at constant velocity. So if you have ever like where you are right now, you may be sitting on a chair. There may be something that is just sitting there. That is statics. The forces that are making that object not to move, to be balanced, that is statics. Or if a car that is moving at the constant speed, it's not changing, that is statics. So that's our first branch, and that is the one that we are going to be focusing on in engineering second year, which is what? Second year first semester, which is statics. It is just concerned with bodies that are in equilibrium or at rest, or moving with constant velocity. And one thing that we should note about statics is the resultant force is equal to what? Is equal to 0. Yeah. Another thing also is imagine standing on a bridge that is carrying thousands of vehicles daily. Why doesn't it collapse? The answer lies in what we call statics, which is the study of forces on bodies at rest. So this is why when you're talking about courses like civil engineering, we are the ones whereby designing bridges. Yeah, even other engineering discipline like mechanical engineering will be fine, can be a structural engineer. Yeah, so for you to design a bridge, you need to design it in a way like the resultant forces there are going to be 0, so that that bridge is not moving, doesn't break and stuff. So it's all about what? Statics. Yeah, so that is the first branch of mechanics, which is statics. So whenever you're asked about the branches of mechanics, there are two: statics and what? Dynamics. Let's go to dynamics. So dynamics we are talking about now, it can be objects that are in motion, and in dynamics we have what we call kinematics and kinetics. So for kinematics we mean motion only, which means movement only. Kinetics is motion plus what? Plus forces. Yeah, so that's dynamics. Dynamics is concerned about, for example, a pulley and stuff, a vehicle. Yeah, that is dynamics. So those are the two branches of what? Of mechanics. Yeah, so here is the summary of how mechanics branches. So we have mechanics. Mechanics branches into statics and dynamics. Statics is all about equilibrium. Dynamics branches into kinematics and what? And kinetics. So for now, for first semester second year, we are only focused on what? Statics, which is bodies that are just at what? At equilibrium, that are not moving. So that is what? That is statics. So here is a quick check. A chair standing still is statics, because every force on it is what? Is balanced. Another one is a car speeding down the road. That is what? That's dynamics. From there, we are done with the first section. Yeah, we go to the second section. So that is just the introduction to what? To statics. So let's go to the second step, which is basic quantities used in statics. Now, we want to talk about the quantities that are going to be used in what? In statics throughout the course. Yeah. And one thing that I want you guys to know about statics is it's a prerequisite to other higher courses, and also it's a foundation to the other courses. So we really need to understand it for us to understand the courses that are coming. Yeah. So the basic quantities that are there for statics, the four basic quantities, we already know them, which is length in meters, time in seconds, mass in kgs, force in newtons. So those are the four basic quantities used in what? In statics. Now let's define, we go to force. We are going to meet force a lot. Just as we said, we are talking about forces being balanced or being equal. Yeah. So we need to know what is this force. Yeah. We already know that force is a pull or push on an object, and we know its quantity. The unit for force is a newton. Now, what is this newton? So 1 newton is just the force needed to accelerate a 1 kilogram mass at 1 meter per second squared. So this is just a force needed to accelerate 1 kilogram mass at what? At 1 meter per second squared. Yeah. And forces show up everywhere. They show Newton. Yeah, forces show up everywhere. They can either show as weight, as tension, as friction, as normal reaction, or wind load. So that is all about what? Forces. Yeah, that is all about what? Forces. We are going to meet forces a lot in what? In statics. Now let's go to section 3, which is idealizations in engineering. So just as I said, when we are starting that, we are also going to cover idealization. Now, what is this idealization? So we are going to find that the real objects are complicated. Real objects are complicated, like bridges and stuff. So engineers simplify them using models called what? Idealizations. So these are just like models that are used to what? To simplify complicated objects. Yeah, because real objects are always complicated. Now, there are three key ones. There are three key ones to know the idealization that we need to know. The three key idealization that we need to know. So here are them. We have a particle, a rigid body, and concentrated force. So when you are talking about a particle, so a particle ignores shape and size, treating an object as just a mass. Yeah. So you'll be finding instances whereby that idealization, for example, a particle, it's going to ignore the shape of an object and the size. So there are instances whereby you want to calculate something, so you're going to ignore the shape and what? And size. Yeah. Treating that object as just what? As mass. For example, a satellite orbiting Earth. Yeah. Another thing is also rigid body. A rigid body doesn't change shape under load. So think steel beams or concrete column. They don't change shape under what? Under load. So that's the difference between particle and the rigid body. And a concentrated force represents a distributed load acting at a single point, like a hook lifting a load. So those are the three idealizations. So we have particle, which has mass only, size ignored. Rigid body, shape doesn't change. So when they ask you what is a rigid body, so this is an object whereby shape doesn't what? Change. What about a concentrated force? This is just load acting at what? At a point. Yeah. So those are the three idealizations. So we are done with section 3. Let's go to another thing, which is Newton's three laws. Yeah. So just as I said, introductory video to statics, it is talking about things that are going to help you understand statics. So Newton's three laws of motion. I'm sure you are already familiar with these laws. So we have the first law, which is the law of inertia. Yeah, we already know the law of inertia. So this one just tells us like when a body is at rest or at a constant speed, it will remain at that rest or constant velocity. Yeah, unless unbalanced force acts on it. That's just the law of inertia or first law of motion, which is just talked about a body which is being balanced. Yeah, remaining at that until a non-zero net force acts on it. We also have a second law of motion. Second of law of motion, this is the law that we have been using a lot. When you write the formula, force is equal to mass times acceleration. That's just the what? Newton's second law of motion. And this is just stating that force equals mass times acceleration. Yeah, but and in statics, acceleration is what? Is zero. So the net force is what? Is 0 too. Yeah, so that's the equilibrium condition we will use throughout this course. Here is a simple example, which is just we have been given the mass to be 5 kg, uh, the acceleration to be 2 meters per second squared. So we are going to find out that the force is equal to 10 newtons. But in statics, acceleration is equal to 0. So even the force is going to be equal to what? To 0. Yeah. So that's just a second law of motion. Let's go to Newton's third law of motion. Yeah. So Newton's third law of motion, this is just stating that for every action, there is an equal and opposite reaction. When I push you, you are going to push me too. Yeah. So that's just Newton's third law of motion. For every reaction, there is an equal and opposite reaction. And this is the law that is making objects to what? To remain in equilibrium. Because when I push you, if there is no equilibrium, you are going to fall down. But when I push you, you are also going to push. We are going to say that, for example, I'm pushing by 5 newtons, you are pushing by 5 newtons. But since we are in opposite directions, what's going to happen is 5 plus negative 5 is going to be equal to what? To 0. The resultant force is equal to what? 0. So that's just Newton's third law of motion. Yeah. Another law also that we need to know is just the law of universal gravitation. Yeah. So whenever we write weight is equal to mass times gravity, I'm sure that's a law we are referring to. So what's there is gravity pulls masses toward each other. And near Earth's surface, that gives every object its weight. So weight equal mass times gravitational acceleration. So this formula that we have been using, weight is equal to mass times gravity, that's just the law of universal gravitation. Yeah. Another, we can also give an example here where the weight of a 20 kg block and stuff. We already know how to calculate the weight of an object. Yeah. So that's just those about laws of motion. Yeah, or Newton's laws. We also go to SI units used in statics. This one also is an introductory video, so some of the things you already know them. Length, it's measured in meters, you already know these things. Mass, kilogram, kg, time, second, SI, we already know these things. So, but you can just write them down, but you already know them. Yeah. But always convert units first. Whenever you are calculating, you are given a question. For example, they give you 100 centimeter. Convert it to what? To 1 meter. Yeah. So here is the conversion. 100 centimeter is equal to 1 meter. 1000 millimeters is equal to what? 1 meter. 1 kilonewton is equal to 1000 newtons. Yeah. So here we come to section 7, which is just general problem solving procedure. So this one is very, very important also. When you are given a question in statics, you don't just run to answering it. Yeah. The first thing is read carefully. Read carefully what you have been given. Also, identify what you have been given. Like you have been given the masses, the forces, then identify what is required. What are you finding? And the fourth thing is draw a diagram, which is FBD. Diagrams will always help you. Then question 5, choose equations. Find the equation that you need to use. Then you go to substitute the values, then you calculate. State answers and what? And the units. Yeah. So always keep this in mind when you're solving a statics problem. Yeah. For example, these are just simple examples. For example, calculate the weight of a 15. Yeah. Simple example. So here are the key takeaways. in statics, statics is all about equilibrium, and we have the basic quantities there: length, time, mass, and force. We also learned about Newton's laws, SI units, also statics versus dynamics. So we now know what's the difference between statics and dynamics, and they are all falling under what? Mechanics. We know the idealization that is there. What is the difference between a particle, a rigid body, and a concentrated force? So if you till now you can't understand what's the difference between, just pause the video and try to go back where I was talking about these things. And forgive me, I was too fast in this video, and the reason being is this is just an introductory video. Yeah, but the next video I will call it, that's a very very first video, because that's where your exam or the test that you are going to write, the questions are going to come from. But this is just telling you what you are going to cover in this course, which is into statics. So thank you guys for watching, and don't forget to subscribe for others to see this video, and to help out the video. Don't forget to subscribe and like for more lesson videos and academic tips.